Hello guys, in today's live stream we will continue our fake news classifier project. So let me open this notebook. So we are running in this, you can say, Google Colab. Here we are training for you can say gradient boosting algorithm. We get around yeah, 87, 0.87 as F1 score for 0 and 0.85 as F1 score for 1. So, but if we compare all, you can say all algorithms, we getting maximum accuracy using this multinomial naive-Bayes algorithm. You can see we are getting F1 score as 0.93 for 0 and 0.93 for 1 as well. So that's why what we do using Pickle, we saved our model in a model.pkl and also we saved our, you can say, vectorizer using same, you can say, pickle.dump bag of word. So then we created you can say, Flask web app. So here what we have to we imported all required libraries and initialize our Flask web app, then loaded our model and vectorizer, and also you can say defined our wordnet limitizer. Then this is our home page. Then we have two other pages, that is real and other is fake. Then what we do, we created a, you can say we imported our text from, you can say, index.html, and then then we start, you can say, text preprocessing. After in text preprocessing, we load the text, we splitted all the, you can say, words, then remove stop words and start limitizing that remaining words, and then join in you can say single text. Then what we have done, we use vectorize is equal to vectorizer dot transform text dot reshape 1 comma. I think for this case we do not need this, and we have to give our text value in a list format, not in a string. And then we prediction is equal to model dot predict. We predict for this, you can say vectorized, or you can say this x value, and we give it as 0 because we want to get just a first value. Then we initialize our, you can say, output as a empty string. If our prediction is 0, then output will be fake, else our output will be real. So if our output will be fake, it will redirect to here, and if our, you can say, output is real, it will redirect to here. So let me save this web app, and also start, you can say, start running this web app. Let's see. So it will take, you can say, time to run. Also, in my GitHub, I do not, you can say, added model.pk and vectorizer.pk because both these models are greater than 50 MB. One vectorizer.pk is around 96 MBs, and model.pk is around 100 MBs. So that's why, but we have a limitation of, you can say, uploading not a file not greater than 50 MB in GitHub. That's why I added this into a gitignore file. So let's go to our web app. Here you can see our web app is running. Let me start predicting. So let's predict for this, you can say, random value. Then let me go to our web app. Here, let me paste it here and let's see. You can see this is the real news. Let's confirm this. So in news.csv, for our first value, our label is so for our first value, our label is fake, but this is giving us real news. Let's again predict for this. Let's see. Here you can see this is the fake news. So this is working fine. Now let me close this web app. For closing this web app, we have to just do nothing. We have to you can see give Control plus C. Here you can see our web app is end, or you can say stopped. So in this time, I will not you can say deploy this on you can say EC2 instance because currently you can say there in I don't have you can say subscription of AWS account. That's why we do not upload the deploy this on AWS. Now let me just you can say uh, commit my GitHub git add git commit -m, and this is our day number 3, and then let's push it to you can say origin main. You can see it is successfully pushed. So here our you can say a project is completed. Now we will you can now we will head towards our next project. Our next project will be dog versus cat classification, that is a CNN problem. Let's go to Kaggle. Kaggle. Here we will search for dog cat dog dataset. We will use this dataset for training. Let me click on this download button. From here, our you can say downloading start. So here we have two directories. One is training set and another is test set. And inside this training set, we have cats and dog images. Here you can see our file is downloaded. Or I can let me copy this and paste it here. Or I will do this later. So let me you can say extract here all these files. It will take some time. Till then, let me create a new directory in my projects. We will give this a cat dog classifier. So again, we will you can say do this in you can say in Google Colab because this is a CNN problem, and in Google Colab we can take use of you can say we can take use of TPUs or GPUs. Let me create a new notebook. Give this file name as cat dog classifier, and I will share this file with you so that you can try by your own. Let's see. It will take time. Let me change my run type. Here we will use a T4 GPU. Here you can see uh, uh, our resource is start, or you can say GPU is started. Or we can do one more thing. Instead of you can say Google Colab, we will start working on this you can say this Kaggle notebook. Here we create a new Kaggle notebook. So we set our you can say processor as a GPU. So here it prints all the file names. Okay. Oh my god, it is too many files. Let me comment it out and also comment it out. Oh, that's now from here we will start importing necessary. Now, first we will import numpy as np. Then we import cv2 because in this we will do, you can say, we will work with images, so that's why. Then also we will import pil dot image as image, and then also we have to import os. Let me here also import pandas. Then afterwards, I think we have to need to import this. You can say pathlib. Then or we can also uh, let me import TensorFlow as TF, and then for visualization here, let me import matplotlib.pyplot as plt, and after that, I guess uh, let me import TensorFlow from TensorFlow. Let me import keras. So let's start working. Before that, we need to uh, install, you can say, PIL. So if you have to, you can say, work with the command line, you have to give this exclamation sign. Install PIL in, you can say, also we need to install pillow. Okay, let's start running. So it is in, it is already satisfied. performance and performance dot filter performance and give this as ignore. And so let me cut this cell and paste it here. And we can also delete this cell. I will start with this. And now we will run this. Now you can see start working with our you can say data. So let's check you can say length of or yes length of os dot directory or os dot list directory, and then we'll give class. Inside training underscore set we have again training underscore set underscore set. We have you can say cats. Okay. We have around so we have around 4,000 different cat images and 4,000 similarly 4,006 different dog images. So now we will check. So we have of 1013, you can say cat, cats. You can say 1012 different, that is, you can say cat images. So total we have, you can say, around 5,000 images, where 20% is for testing part and 80% is for training part, we can say. Now let's give the image size. Let's assume it will be this. Now what will we do? Now we will, you can say, define dogs for training, dogs for testing, and cats for training and cats for testing. For that, we will need to create a loop. Then dog, train dog, train cat, test dog, test cat is equal to, and then for image in, let me give this address. image is equal to cv2 dot im read string dot image image, and we will give our image shape. You can see now we will append this in. So this is train underscore dog dot append resize image. Now let me I think we need to give you can see we are getting warning because we need to give this complete you can say address. And you can see we get our value. Delete this. I'm sorry. So here we have to give this string also. Let's start. Here you can see decoding string is not spotted. Where we are getting error. So now let's start you can say loading all the images. There is problem and realize here you can see open CV. So here I think here you can see we get our expected data. Here let me see is every value has or you can see no we have to resize all these images because all these images are not of same size. Now now here let me give a 40,40. Let's see how it works. Still we are getting it. Let's try GPT. In resize function. The most common fix. Yes, we can do a if else condition. And likely this is what laundry format. Let's see for how much value we will get. Let's training this. Okay, there is one file name ts. Inside this training set gets we have a file ts store. Okay. So this is executed. Now we will do it for now. Let's check train underscore dog dot shape. So it is a list. PD dot data frame. Then we will give a data that is train underscore dog. Then we will give dot shape. Let's see. So its input shape is, you can say we have 4,000 different images with 200 comma 200, and we have, you can say, for all channels for R, G, and P. Okay. Now I have added this code, and now this will train cat. Oh, so it is for cats. We have to append this in train cat, and this is for dog. So it will be dogs. This is for test underscore cat. Dogs, dogs, and here test dog. Fail to read image in training set. Let's start from this. So now what we will do, so now we will try to give this in array form. Let's see. I can go to this. Here you can see we are getting a 4005 comma 200 comma 200 comma 3 as it here. Okay. Now we will create a data frame. So let's try pt dot date frame. Here we give our list and that is data is equal data will be our train underscore dog. Let's see. So okay. Let me check. So I so these are my notes. Okay. Then photo level you can see. The resignation behind the add processing layer to front of VGG. Okay. We have to import from here. minutes. And your image size is this. Now we loaded our VGG16 model, and before that we have to define our pattern. We can simply have that also a note to import model also. So here our, you can say, length is 2, because we have two categories. One is you can say, one is drawing, another one is, you can say, let me use image shape here. So here you can see our model is ready. Just we have to, We can do one thing here. Instead of this, we can give this x train comma y, or even the x test comma y train comma y test is equal to empty list. Okay. So here what we will do, we will append this in x train, and these all are gets, so we will give y train dot append and our value will be 0. We will do, and then it is our x test, and that's this. So let's check the x train, then y train, then length of x test, then length of, you can say, y test. Okay. So we have equal, you can say, length y test. You can say we have 0 and 4. We have 1. Cool. Now we will give this in array form, convert our image into array. X is equal to np dot array. Also we have x string. Oh, I'm really let's see the image. PLT.im show. We will give some random number. You can see we have, you can say, cat image. Now we will perform a normalization. Okay. So this one, I think we should divide this by 255 or 256. With 255. Okay. I think here I trained all normalized by tractor. You can see I rescaled 255. Uh, Now let's train using this model, or we can remove this model. In our later part, we will, I can say, train using this model. Now, before that, we need to import on this. Let's start our model creation. Keras dot sequential. Here we will Keras dot layers. We will add layer. Then we will start with convolution layer 2D. Convolution 2D. Here our filters is equal to 32. Kernel size will be 3,3. And here our activation function will be value. Here our input shape will be equal to put underscore shape. So here we are, you can say, seeing our VG19 model. Here we have ReLU iteration function. Okay, and at last we have softmax. Okay, now we go to the model. Here here we will do you can say max pooling layers dot max pool to D and pooling size will be 2 comma 2. Again we will add you can say convolution layer. This time our filters size will be 64 and again kernel size will be 3 comma 3 and activation function will be still ReLU. This time we do not need to give this you can say input shape. Again we give our you can say max pooling layer. Let me create a third you can say for 128 filters and then we will do keras dot layers weird flattening layer flatten layer. Then we add a dense layer dot dense. Here we will give 10 or activation. Yes, still we give a 0. Actually, it is quite long. I do not work, so I you can say it's long time working on the CNN problem. That's why I'm struggling a lot. Okay, then here we give our activation based softmax. After this, we will do model dot compile. Here we will mention our uh, optimizer. Our optimizer will be Adam. Then our loss function will be you can say we will give our here I will give binary class entropy. after loss, we have to give we have to define our mat matrices, and this will be accuracy. After that, we will fit our model using dot fit x train comma y train comma for you can say current we will give epoch size will be around 10. Yes, it is image. Let's start fitting. I think we need to convert this into multiple batches. So we will do it tomorrow. Uh, or you can see we tomorrow we will convert this into batches, and after it we will move forward to a trend. Let me see if they let me download this book also. So I think this is enough for today. Thanks for watching.